The signal began as a pulse, a rhythmic, relentless chirping that sliced through the static of the upper atmosphere and settled into the headphones of amateur radio operators across the globe. It was October 4th, 1957, a Friday evening that would dismantle the psychological infrastructure of the United States. The source of the sound was a polished aluminum sphere, 23 inches in diameter, weighing a mere 184 pounds. It was Sputnik 1, and as it traced its elliptical path over the American heartland, it did not merely broadcast a radio beep, it broadcast the terrifying obsolescence of American power. For the men inside the Strategic Air Command, ESAC, this was not a scientific marvel. It was a tactical catastrophe. The United States had spent the decade following World War II operating under the comforting delusion of invulnerability. They possessed the strategic bombers, the atomic stockpile, and the industrial base. But Sputnik shattered that illusion in 96 minutes, the time it took the satellite to complete one orbit. If a Soviet R-7 rocket could place a satellite over Washington, D.C., it could just as easily deposit a thermonuclear warhead on the White House lawn. The high ground of space had been seized, not by the victors of Midway and Normandy, but by a nation the American propaganda machine had dismissed as technologically inferior. The reaction within the Pentagon was visceral. The air in the corridors of power grew thick with a specific brand of panic, the fear of the missile gap. Intelligence reports, often exaggerated but accepted as gospel, painted a grim picture of Soviet assembly lines churning out intercontinental ballistic missiles, ICBMs, like sausages. The public hysteria was fueled by the media. The New York Times was averaging 11 articles a day on the satellite, stoking a national anxiety that bordered on neurosis. The American response, a hastily assembled Navy project called Vanguard, crumbled on the launch pad in December, exploding in a ball of humiliation that the international press dubbed Kaputnik. In the offices of the Air Force leadership, the humiliation was intolerable. General Curtis LeMay, the architect of the strategic bombing campaign against Japan and the commander of SAC, was not a man who dealt in subtleties. He believed in overwhelming force and the psychological dominance of the enemy. To men like LeMay, deterrence was a matter of perception. If the world believed the Soviets were stronger, then they were stronger. The United States needed to regain the initiative, and they needed to do it with a gesture so grand, so violent, and so undeniable that it would silence the Soviet chirping forever. The search for this grand gesture moved beyond the atmosphere. Launching a satellite was no longer enough. The Soviets had done it first. The United States needed to do something the Soviets hadn't done, something visible to the naked eye of every human being on Earth. The military. Planners looked up at the night sky and saw their target. It was massive, silent, and watched by half the planet at any given moment. It was the moon. The concept that began to form in the classified briefings of early 1958 was grotesque in its simplicity. The Air Force did not want to explore the moon. They wanted to brand it. They wanted to denote a nuclear weapon on the lunar surface. This was to be a psychological operation of cosmic scale. The explosion had to be bright enough to be seen from the streets of Moscow and the suburbs of New York. It was to be a mushroom cloud rising in the vacuum, a permanent reminder that the United States possessed the power to touch the heavens and burn them. As the winter of 1957 turned into the spring of 1958, the machinery of the military-industrial complex began to turn toward this dark ambition. The project required secrecy, scientific cover, and a team capable of solving the ballistic nightmare of hitting a moving celestial body with a nuclear warhead. The order went out to find the physicists who could make the math work. The Air Force was done playing catch-up. They were preparing to escalate the Cold War to the stars. The panic of the Sputnik moment set the stage for a meeting that would bring the military's darkest ambitions to a quiet research facility in Chicago. May 1958. The wind off Lake Michigan carried the last bite of the Chicago winter, rattling the windows of the Armour Research Foundation. Inside the brick walls of this prestigious institute, located on the campus of the Illinois Institute of Technology, the atmosphere was usually one of academic quiet and industrial innovation. The foundation was a place where science met application, a hub for researchers who solved problems for both the government and the private sector. But on this particular morning, the problem walking through the door was unlike anything Dr. Leonard Reiffel had ever encountered. Reiffel was a physicist of rising renown, a man who navigated the worlds of nuclear physics and electrical engineering with a sharp, pragmatic intellect. At 30 years old, he had already worked with Enrico Fermi and had established himself as a capable leader who could handle sensitive government contracts. He sat in his office, surrounded by the clutter of schematics and reports, waiting for a delegation from the United States Air Force. He knew they were senior officers, men from the high echelons of the strategic planning divisions, but the specifics of their visit had been kept deliberately vague. When the officers arrived, they filled the small conference room with the stiff, starched energy of the military. These were men who carried the weight of the Sputnik crisis on their shoulders. They were not interested in theoretical physics for the sake of knowledge. They were interested in results. They represented the terrifying anxiety that had gripped Washington, the belief that the United States was losing the narrative of history. The briefing began with the usual formalities, but the preamble was short. The senior officer, a man whose demeanor suggested he was accustomed to giving orders that altered landscapes, leaned forward. He spoke of the national morale, of the perceived weakness of the West, and of the need for a demonstration that would be unequivocal. He laid out the Air Force's requirement. They needed a visibility study. Reiffel listened, his mind racing to categorize the request. Was it a new radar system? A missile defense shield? Then the officer dropped the veneer. "We want to detonate a nuclear device on the moon," he said, his voice flat and serious. "And we need to know if the flash will be visible to the naked eye from Earth." The room seemed to contract. Reiffel stared at the officers. They were proposing an intercontinental ballistic missile shot not at a Soviet silo, but at the lunar surface. They wanted to create a man-made star on the moon, a flash of nuclear fire that would serve as a billboard for American supremacy. The officer explained that the primary objective was not scientific, it was political. It was a PR exercise designed to show who the leader was. Reiffel's scientific mind immediately began to catalog the impossibilities. The moon had no atmosphere. A nuclear blast on Earth creates a mushroom cloud because of the air resistance. In a vacuum, the explosion would be a spherical expansion of gas and radiation. Would it be bright enough? Would the dust stay aloft long enough to be illuminated by the sun? And then there was the guidance system. Hitting a target 238,000 miles away with the primitive rockets of 1958 was a gamble of the highest order. But beyond the physics was the sheer audacity of the moral transgression. They were asking him to blueprint the desecration of a celestial body. They were discussing the radioactive contamination of a world that remained pristine, untouched by human folly. The senior officer watched Reiffel closely, gauging his reaction. He needed a physicist who wouldn't just do the math, but who would keep the secret. "We need a feasibility study, Doctor," the officer said, drumming his fingers on the heavy table. "We need to know the yield, the payload, and the visibility. And we need it fast." Reiffel looked at the men. He saw the desperation in their eyes, the fear of a Soviet domination that drove them to consider madness as strategy. He took a breath, weighing the scientific challenge against the ethical abyss. The officer raised an eyebrow, waiting for the answer that would initiate one of the most dangerous projects in human history. "Well, Doctor," the officer asked, the question hanging heavy in the silence. "Can we make the world see it?" Reiffel opened his mouth to speak, and... While Reiffel weighed his answer in Chicago, the machinery of the project was already grinding into motion, requiring a team of minds to turn the military's desire into mathematical reality. The project was given the cover name a study of lunar research flights, a bureaucratic euphemism designed to sound like a dull academic inquiry into rocketry trajectories. But behind the closed doors of the Armour Research Foundation, the work was anything but dull. Dr. Reiffel, having accepted the commission, moved quickly to assemble a team that could answer the Air Force's grim interrogatives. He needed more than just nuclear physicists. He needed experts in planetary astronomy, men who understood the lunar surface not as a poetic concept, but as a physical target. Reiffel recruited 10 researchers for the core team. Among them was Dr. Gerard Kuiper, a titan of 20th century astronomy. Kuiper was the man who had discovered moons around Uranus and Neptune, a scientist whose name would eventually adorn the belt of icy objects at the edge of the solar system. His involvement lent the project an immediate, if uncomfortable, legitimacy. Kuiper, however, was a busy academic, and the grunt work of the complex mathematical modeling required a mind that was both brilliant and available. It was Kuiper who brought in his doctoral student from the University of Chicago, a 24-year-old named Carl Sagan. In 1958, Carl Sagan was not yet the turtleneck-wearing icon of Cosmos. He was a precocious, intensely curious graduate student, recently married to the biologist Lynn Margulis, and hungry to make his mark on planetary science. Sagan possessed a top-secret clearance, a necessity for the work Reiffel had in mind. He was assigned the most critical task of the entire project: the mathematical modeling of the dust and gas cloud that would be generated by the nuclear blast. This was the linchpin of the Air Force's request. The generals didn't care about seismic data or lunar geology. They cared about the spectacle. They needed to know if the explosion would be visible to the naked eye. Sagan plunged into the calculations. He had to model how a nuclear fireball would behave in a vacuum and under 1/6 gravity. On Earth, the atmosphere contains the blast, shaping it into the mushroom cloud. On the Moon, the cloud would expand explosively in all directions. Sagan had to determine if the cloud of pulverized regolith would remain dense enough to reflect sunlight and create a visible spot against the dark lunar terrain. Sagan worked with a strange duality. On one hand, he was helping to plan a nuclear strike on a world he desperately wanted to explore. On the other, he saw a sliver of scientific value in the madness. At the time, there was a prevailing theory, one Sagan found intriguing, that organic molecules or even microbial life might exist beneath the lunar surface. He reasoned that the explosion might vaporize the surface material and loft it into space, where the dust could be analyzed for signs of life. It was a Faustian bargain, using a weapon of mass destruction as a tool of biological discovery. Between May 1958 and January 1959, the team produced a series of detailed reports. These documents, classified for decades, analyzed the thermal effects, the radiation propagation, and the optical visibility. They were weaponizing astronomy. The team worked in a secure environment, the pressure of the missile gap constantly in the background. They were young scientists solving new physics problems, but the solution to their equation was a mushroom cloud on the Moon. Sagan's calculations confirmed what the Air Force hoped. It was possible. A specific type of detonation, timed perfectly, would create a cloud that would catch the sun's rays while the surface below remained in darkness. It would be a new star, a temporary beacon of American might. The science was sound. Now, the military had to provide the hardware to deliver the apocalypse. With the math confirming the visibility, the focus shifted to the terrifying mechanics of the bomb itself and the unreliable rockets that would carry it. The ambition of Project A119 was matched only by the fragility of the technology available to execute it. In 1958, spaceflight was in its infancy, a chaotic discipline defined as much by catastrophic explosions as by successful launches. To deliver a nuclear warhead to the Moon required a convergence of ballistics, nuclear engineering, and timing that pushed the limits of what was physically possible. The first hurdle was the weapon. The massive hydrogen bombs that were being tested in the Pacific, devices capable of vaporizing islands, were far too heavy to be lifted to lunar escape velocity. The Air Force needed a warhead that was compact, lightweight, yet powerful enough to kick up the massive dust cloud Sagan had modeled. The choice fell on the W-25 nuclear warhead. The W-25 was a marvel of miniaturization. Developed for the Genie air-to-air rocket, a weapon designed to be fired from fighter jets to destroy formations of Soviet bombers, it was a fission device with a yield of 1.7 kilotons. While small compared to megaton-class city killers, 1.7 kilotons was still roughly a tenth of the power of the bomb dropped on Hiroshima. Crucially, the W-25 weighed only about 220 pounds, 100 kg, and was just 26 inches long. It was small enough to fit into the nose cone of a medium-lift rocket. The delivery vehicle was the next nightmare. The primary candidate for the mission was the Atlas missile, or a hybrid variant like the Atlas Able. The Atlas was the first operational U.S. ICBM, a beast of a machine built with stainless steel tanks so thin they had to be kept pressurized with nitrogen gas when empty, or they would collapse under their own weight like a deflated balloon. It was powerful, but it was temperamental. Throughout 1958 and 1959, the U.S. space program was plagued by failures. The Pioneer lunar probes, which used similar Thor Able and Atlas Able launch vehicles, suffered a humiliating streak of disasters. Rockets exploded on the launch pad, broke up during ascent, or failed to ignite their upper stages. The prospect of strapping a live nuclear warhead to a rocket that had a significant chance of blowing up seconds after liftoff was a source of extreme anxiety. Then there was the targeting. To achieve the visibility the Air Force demanded, Reiffel's team determined that simply hitting the moon wasn't enough. If they hit the bright, sunlit side, the glare would wash out the flash of the bomb. If they hit the dark side, the cloud would be invisible. The target had to be the Terminator line, the moving boundary between lunar day and lunar night. The plan called for the missile to impact on the dark side of the Terminator. When the W-25 detonated, the explosion would throw tons of pulverized rock and dust miles into the vacuum. As this cloud rose, it would climb into the sunlight streaming over the lunar horizon. Backlit by the sun against the blackness of space, the cloud would glow brilliantly. To an observer on Earth, looking through a telescope or even with the naked eye, it would appear as a sudden, expanding point of light on the shadowed edge of the moon. The margin for error was non-existent. The guidance systems of the era were analog and rudimentary. A deviation of a fraction of a degree during the launch phase would result in the warhead missing the moon entirely and drifting into solar orbit, a lost nuclear needle in a cosmic haystack. Yet, the engineers and scientists pressed on, driven by the directive to provide a capability. They had the bomb, they had the math, and they had the rocket. But they weren't the only ones. As the Americans struggled with their rockets, a mirror image of their project was taking shape in the Soviet Union, driven by the same fears and the same physics. While Reiffel and Sagan toiled in Chicago, a strikingly similar drama was unfolding in the closed cities of the Soviet Union. The Kremlin, despite the triumph of Sputnik, was gripped by the same insecurities that plagued Washington. They knew the American industrial giant was waking up. To maintain the illusion of total dominance, the Soviets needed to continue their streak of firsts. In early 1958, the Soviet government authorized the E-Project series, a roadmap for the conquest of the moon. The E-series included plans to impact the moon, E1, and to photograph its far side, E2, E3. But the final, most ominous entry was Project E4. This was the Soviet twin of A119, a mission to deliver a nuclear strike to the lunar surface. The intellectual force behind Project E4 was Yakov Borisovich Zeldovich. Zeldovich was a physicist of immense stature, a three-time hero of socialist labor who had played a key role in developing the Soviet hydrogen bomb. Like Reiffel, he was a man whose brilliance was harnessed by the state for military ends. But Zeldovich was also a cosmologist, a man who looked at the universe with awe. For the Soviet military planners, the motivation for Project E4 was proof. Sputnik had been a radio signal. A nuclear flash on the moon would be visual confirmation that Soviet guidance systems were precise enough to hit a specific celestial target. It was about proving to the world that their rocketry was not just powerful, but accurate. The intelligence war fueled this parallel madness. Rumors circulated in the Western press about Soviet lunar intentions. A United Press article even speculated on the Soviet plan to nuke the moon, which likely spurred the Americans to accelerate their own planning. The Soviets, in turn, were watching the Americans. They knew about the Discoverer satellites and feared the U.S. was moving to militarize space. However, Zeldovich faced the same terrors that haunted Reiffel. The R-7 Semyorka rocket, the workhorse of the Soviet space program, was powerful but dangerous. The Soviet launch facilities at Baikonur were deep inland. If an American rocket failed, it likely fell into the Atlantic Ocean. If a Soviet rocket carrying a nuclear warhead failed during the boost phase, it could crash onto Soviet territory, irradiating their own people. Moreover, the Soviet scientific community began to voice the same concerns as their American counterparts. Zeldovich, despite his role in the bomb program, understood the scientific value of the moon. He knew that detonating a nuclear weapon would contaminate the lunar environment, ruining it for future study. The radioactive fallout would settle on the surface, creating a background noise that would blind future instruments. Project E4 existed in a state of high tension. The political leadership wanted the spectacle, the scientists wanted the data, and the engineers feared the catastrophe of a launch failure. By 1958, both superpowers were staring down the barrel of the same gun, holding plans for the same celestial vandalism. They were both ready to pull the trigger, waiting only for the order that would turn the Cold War into a war on the cosmos itself. The plans were drawn, the rockets were selected, and the scientists on both sides had done their duty. Now, it all came down to a final decision in a conference room where the risks were finally weighed against the pride of nations. "Yes," Dr. Reiffel said, his voice steady in the quiet conference room. "We can make them see it." He looked at the senior officers, seeing the anticipation in their posture. He explained the conclusion of the reports. A W-25 warhead, impacting the lunar terminator, would create a dust cloud illuminated by the sun. It would be visible. It would be the grand gesture they desperately wanted. But then Reiffel delivered the caveat that would ultimately save the moon. He shifted the discussion from physics to probability. He laid out the terrifying reality of the launch vehicles. The Atlas and Thor-Able rockets had a catastrophic failure rate. He painted a picture not of a triumph on the moon, but of a disaster in Florida. If the rocket exploded on the launch pad at Cape Canaveral, a common occurrence in 1958, the high explosives in the nuclear warhead could detonate. It wouldn't be a full nuclear yield, but it would be a dirty bomb scenario, scattering plutonium across the launch complex and potentially drifting over populated areas. The risk, Reiffel argued, outweighs the propaganda value. Furthermore, the scientific team had bolstered their case. They argued that the radioactive contamination of the moon would be a permanent scar. It would destroy the pristine lunar environment, making it impossible to study the moon's natural radioactivity or search for the organic markers Sagan was so interested in. If the U.S. intended to send men to the moon one day, and by 1959, NASA was already dreaming of this, they would be landing in a radioactive wasteland of their own making. The Air Force leadership, faced with the prospect of a nuclear accident on American soil and the alienation of the scientific community, finally blinked. The Sputnik panic was beginning to subside as the U.S. achieved its own satellite successes with Explorer 1. The need for a suicidal PR stunt diminished. In January 1959, the project was quietly canceled. The files were locked in safes, the reports classified, and the team disbanded. For decades, Project A119 remained one of the Cold War's deepest secrets. But the secret was nearly exposed almost immediately. In March 1959, a young Carl Sagan, perhaps naive to the strictures of the military or simply eager to impress, applied for a prestigious fellowship at the Miller Institute at the University of California, Berkeley. In his application, listed under his academic accomplishments, Sagan included the titles of 2 classified papers he had written for the project. Possible contribution of lunar nuclear weapons detonations to the solution of some problems in planetary astronomy and radiological contamination of the Moon by nuclear weapons detonations. It was a stunning security breach. When Reiffel later learned of it, he was horrified, noting that Sagan had violated national security. Had the Air Force caught the leak at the time, Sagan's career and the future of Cosmos might have ended in a federal prison. But the leak went unnoticed by the public, buried in the paperwork of a university administration. It wasn't until the year 2000, over 40 years later, that the full truth finally emerged. Dr. Leonard Reiffel, then 73 years old, broke his silence in an interview with The Observer. He confirmed the existence of Project A119, revealing that the United States had seriously planned to bomb the Moon to intimidate the Soviet Union. He expressed his relief that the project had never gone forward, describing it as a PR exercise that could have ruined the Moon for science. Project A119 stands as a chilling monument to the paranoia of the Cold War. It is a reminder that in the rush to conquer the stars, humanity nearly destroyed them. We didn't go to the Moon to bomb it. We went to explore it. But the difference between those 2 futures hung on a razor's edge, decided in a quiet room by men who realized that some victories are too expensive to win.